So I wrote the exam yesterday, and there are basically, at the beginning of the exam, I think there's 22 or 23 multiple choice questions. And if you look at the terminology at the end of the chapter, there's 22 or 23 terminology questions. So make sure you use Quizlet to beef up on that terminology, and you should be fine on the multiple choice part of it, on the initial multiple choice. And then I went ahead and incorporated some of the problem questions that we've got into multiple choice. So we'll kind of take a look at those. So I gave everybody a handout, and so that handout, let me go ahead and switch to the document camera here. And so on that handout, we're just basically going to start out with some of those questions about what happens when we add or subtract, right, capacity in services. Okay, so there's a couple of things that I want to talk about as we look at this, because there's more than just the couple of options you've got on your practice problems. So let's go through these couple, and then we'll talk about some other options as well. Okay, so the first question says, a mail order firm has a total of 10 Watts lines. Excuse me. A mail order firm has a total of 12 Watts lines coming into the customer service department, which has 5 customer service reps, right? And on average, 2 potential customers call the customer service department every minute. Each customer service rep requires an average of 2 minutes to serve a customer. On one of the days, 2 of the Watts lines happens to be down, which results in only 10 Watts lines being available for that day. So, we are talking about capacity for service operations. So we can either increase capacity by adding lines or decrease capacity if, in this instance where we have 2 lines down. So when we decrease capacity, so when we go from 12 lines to 10, right, how many, our customers that are calling in, are more customers going to get a busy signal, less customers, or it doesn't change how many are going to get a busy signal? What do you think? We had 12 available lines, and now we have only 10. So what's going to happen to those customers when they call in?
It's going to increase
Right. It's going to increase the number of customers getting a busy signal because there's not as much capacity for them to call into. Okay? And then, so I don't have as much capacity for them to call into, so are waiting times going to increase, decrease, or remain unchanged? What'd you say, Kayla?
Are they going to increase?
Okay, and why do you think they're going to increase?
Just because there's already 2 lines that are cut, and it's already increasing how many or how long they have to wait, so it's going to even increase the waiting time even more.
Except they can't get in, right?
Oh,
so because we have less capacity, they can't even get into the system to wait. So they actually will have to wait less time. Okay? So are you tracking with that? Because it's important that you are making that connection.
Hold on. So if they have less, they can't get into the system, why would their wait time be less? Wouldn't it be unchanged?
So their wait is less. So before, if I was the 12th caller to get into the system, I was going to have to wait through 12 customers to be served. Now there's only 10 customers in the system. I can't even get in if I'm that 12th caller. So if I'm the 10th caller now, I'm only going to have to wait through 10 to get help. Does that make sense?
Yes.
Okay. And then how about the average utilization of customer service reps? Is it going to increase, decrease, or remain unchanged?
Remain unchanged.
Remain unchanged. Is it going to increase?
Okay. So before, if I'm the customer service rep, I can, as things start to taper off, so let's say you're coming away from your busy time, I was going to have 12 people waiting for me. Now I'm only going to have 10 people waiting for me. So I'm going to be less utilized because those 2 people that were potentially going to get into the waiting system can't ever get there. And as it tapers off, I won't be able to serve.
So won't it not taper off as much because the people are still going to call back?
That's an assumption that isn't exactly true. So not everybody calls back. Okay? So that's one of the things when people get blocked, there's a certain percentage that just go someplace else, right? Okay? Okay,
it's
so
increase, decrease, decrease.
increase, decrease, decrease. Okay. All right, let's look at the next example and talk about it. Okay, so the next one is a mail order company has one department taking customer orders and the other handling customer complaints. So currently each department has a separate telephone number and each has 7 Watts lines served by 2 customer service representatives. Calls come in at the rate of 1 per minute, and each customer service rep takes on average a minute and a half to serve a customer. A proposal has been put forward to merge the 2 departments and cross-train the workers. The new department would, as a result, have 14 Watts lines served by 4 customer service reps. Okay, so let's think about just conceptually what happens when we do that. Okay, so we've got 2 separate departments, and each department has 7 lines each, right? So when we combine up, what's the advantage? Why would we want to combine up? What's the advantage to that?
Does it start with the B, not the blocking?
No, so it's not necessarily it is a little bit about the blocking, okay? But just generally speaking, what's the advantage to trying to combine up these 2 service departments?
Well, your
cost is going to go down.
The other one could do it.
That's right. So you've got this, if one department's busy, the other one can cover it, right? And so if one department's busy and the other department can cover it, what you're saying is we're going to average out the variability, right? Because I could have one department that's busy now and one department that's not, and before, if this department was busy, some customers may not get served, right? If I combine them up and I average out that variability, that when you combine up groups, it's a statistical kind of fact that when you combine up 2 groups and you average out that variability, then that makes the variability less across the entire group now. Okay, so that's our advantage, why we want to do it. So we're going to average out that variability. So if we average out that variability, is the proportion of callers getting a busy signal going to increase, decrease, or remain unchanged?
Decrease.
It's going to decrease, right? Because before, when one department was busy, they'd get bumped out. Now that we have 14 lines available, they'll mix and match better across those 14 lines as opposed to 7. Okay, so again, we're averaging out that variability. So is the average utilization of customer service representatives going to increase, decrease, or remain unchanged?
Increase.
It's going to increase, right? Because now, when I wasn't busy before, right? Now I'm helping out someone else, and I can be busier then. Okay. So those are a couple of examples. Let me go ahead and give another one. So we talked about, well, if we decreased the number of Watts lines that were available, right? And if we decrease the number of Watts lines that were available, we understand what's going to happen. What happens if we increase the number of Watts lines that are available? So let's say instead of on 8.1, instead of decreasing, we're going to increase those number of Watts lines. Okay? So if I increase the number of Watts lines that are available, are the proportion of potential customers getting a busy signal, will that increase, decrease, or remain unchanged?
Decrease.
Decrease, right? And the average waiting time that customers will experience, will it increase, decrease, or remain unchanged?
Increase.
It's going to increase. So everybody's making that connection now between if I have 12 slots and I have 12 people waiting and I add 2 more lines, that means people have to wait longer to get up to the beginning of that line. Okay? And the average utilization of customer service representatives, if I add 2 more lines, is it going to increase, decrease, or remain unchanged? It's going to increase.
Yeah.
With confidence. It's going to increase. Yeah. Because now instead of not having those last 2 slots full, right, I'm going to have the option of serving those customers that I wouldn't have served before. Okay? All right. So you've kind of the 3 things that we talked about were if I increase the number of watts lines, if I decrease the number of watts lines, and if I combine areas and where that reduces the variability, right? Okay, so you want to make sure that you're comfortable with those. I have, rather than, they're set up as just multiple choice questions on the exam, so, but it'll just be increase, decrease, or remain unchanged. And then I've also done the last couple of problems. I went ahead and put them in Respondus. And so when I put them in Respondus, the printout doesn't look exactly, it looks close to what we get when we input it into the copy performance.xls. But you want to make sure that as we talk about this, that you're comfortable, that you're comfortable with how those look. All right. So I've got that, how that copy of performance.xls looks. All right, so what I want to do is I want to go ahead and turn our attention to this problem. Okay, and so 8.3 says a catalog retailer has a customer service representative to take orders on an 800 telephone number. Assume, for example, or for simplicity, that any number of incoming calls can be put on hold and that nobody hangs up in frustration over a long wait. So suppose that on average one call comes in every 3 minutes and it takes the CSR an average of 2 minutes to take an order. Okay, the CSRs are paid $30 per hour and the telephone company charges $10 per hour for the 800 line. The company estimates that each minute a customer is kept on hold, it costs it $4 in customer dissatisfaction. Okay, so as we look at that, okay, the first thing is I'm going to ask you to identify, if you were going to input this into the performance.xls spreadsheet, what's the data that you would use. Okay, so in this example, it says a catalog retailer. So what does C stand for when we're doing performance.xls?
Number of servers.
Number of servers. So how many servers do I have in this example?
1.
1. Okay. And what does R sub I, what does that represent?
Arrival rate.
The arrival rate. Okay. And so what's my arrival rate in this one?
3 minutes.
Okay. Is it 3 minutes?
Or 2.
What's my arrival rate? It has 3 minutes in it, but it's not 3 minutes.
3 divided by 1.
What's that?
Is it 3 divided by 1?
Other way around.
1 divided by 3.
So it's one customer every 3 minutes is my arrival rate, right? So it's 1 over 3, which is 0.333, okay? And the 1 over T sub P represents my processing rate. So what's my processing rate? How do I figure my processing rate? 1 over T sub P. What's T sub P?
Is that your 2 plus 3? Or no?
So 1 over T sub P represents my processing rate. So I'm saying I can process one customer every
2 minutes.
2 minutes, right? So it's 1 divided by 2. So it's 0.5. And both of those are in customers per minute. Okay, now I'm going to switch over to, right, the view of what the performance.xls spreadsheet looks like. And we're going to answer the questions then. So now that we have input our information into performance.xls, and what I'll do is give you a screenshot. The only trouble is this area right here, whatever's highlighted comes out funky, which isn't a big deal because you're not using that information in answering. Okay, the rest of it looks pretty close to like this. Okay, and so that being said, if I ask you based on this information, what's the proportion of time that customer service representatives will be busy? Where am I going for that information? Zach, do you know?
Would it be the is it an average number of waiting in the queue in the K?
Nope. Say you said it was the average number waiting in line? Nope.
Yeah.
So I'm talking about how often those servers are going to be busy, right? Spencer, what do you think?
The servers are busy. Is
Yeah.
it the 66%, 66.66?
Right. So when it says what's the proportion of time that they'll be busy, you're going to use the average utilization of your servers, right? That's 66.66%. Okay? If I were to say, let's just walk down through here real quick and let's refresh. It's been since Thanksgiving since we've looked at these, or, some of you have done a few of them this week. But so let's look at that top information is what we input, right? We input the number of servers, we input the arrival rate, and we input the service rate for each server, okay? I sub I, what does that represent? That's that first line. What does it represent?
Those waiting in the queue.
Right? It's just those that are waiting in line. So it's giving me a number of customers that are waiting in line. What about T sub I?
How long they wait in line?
How long they wait in line, right? Average utilization of servers is the proportion of time that those servers are going to be busy. What about at the bottom where it says my inventory is equal to 1.999? What does that represent? Connor, you've been quiet today. What does the I sub I, or what does the I represent? The very bottom, average number in the system, right? Since I just read it to you.
You want it? I'm sorry, I've been
It's okay.
texting somebody. I have, so.
So it represents the total number of customers in the system, right? So if we have I representing the total number of customers in the system, and I sub I representing those waiting, if I wanted to know how many were in processing, what would I do? How could I get that? So I know the total number in the system, and I know the total number that are waiting.
Add them.
Subtract them. Yep. So if the total number in the system is basically 2, right, and there's 1.3 that are waiting, that tells me that on average there's 0.7 that are being processed. Okay? All right. So now we've kind of gone through all of the kind of key pieces of information. The bottom one, the T, represents the total time in the system. So if I wanted to know then the average time that is in processing, right, I can take my total T and subtract out the time that they spend in waiting, and that's going to give me the time that they spend in processing, right? All right. So that being the case, now let's answer the question. The average time that a customer will be on hold. Emily, how long will a customer be on hold?
Is that the average number waiting in the queue? Oh no.
So when it says the average time, so I'm going to be looking for a T variable, not an inventory variable. So the average time that a customer will be on hold.
Be the waiting time.
It would be the average waiting time, 3.99 minutes, right, or 4 minutes. Okay. Hunter, the average number of customers on the line. I sub I, right? That's the average number of people that are waiting is I sub I. So it's going to be 1.3. Okay? All right. The total hourly cost of service and waiting. Okay, so we know that it costs us something for the people the workers. So we know that our CSRs are paid $30 an hour, and we have one, right? So if I come here, I can go, well, my service costs are $30 an hour for one server, right? So it says, suppose that on average one call comes in every 2 minutes You've got 2 minutes to take an order. CSRs are paid $30 an hour, and the telephone company charges $10 an hour. So it's $30 an hour for the server plus $10 an hour for the watts lines, okay? And then I have to think about, there's two other pieces of the equation when we start to think about cost, right? One of them is the margin loss due to blocking, and the other one is the average cost of waiting, okay? But we're in an infinite system right now, right? We're saying that, let me double check that. Yeah, we're saying right now that there's an infinite capacity for them to be on hold, okay? And so because we're saying that, there's no blocked call, right? Because we're saying that they can get on hold there, okay? And the average cost of waiting is going to be our cost per time times I sub I. And what it tells us is that we've got, it's $4 per minute for customers for dissatisfaction, right? So if I'm interested in an hourly rate, what do I need to do? Andrew?
So
I've got $4 per minute, and I need to convert that to an hourly rate.
you just multiply it by 60.
Right, so I take it times 60 minutes per hour, and then I multiply it times I sub I, right? And if we look back, our I sub I, we said was, I think, 1.333. And so once I finish that math, I'm going to add those together and get my total cost, right? Because in an infinite system, I don't have any blocking. Okay? All right. And then it says, for part C, it says, then let's suppose that our catalog retailer has 5 telephone lines. So what does that mean? How does that change how we use performance.xls?
It's not infinite anymore.
It's no longer infinite, so we go to the finite tab, right? And we replug our information into the finite tab. And in order to do that, we have to know what our K represents. So the K is the queue capacity. So if I have one server and 5 lines, what's my queue capacity? 4, right? Because it's the number of lines that you have minus the number of servers that you have, right? So we would plug that in, right? And we would get this information. We would say we have one server, we have a queue capacity of 4, our arrival rate and our processing rate stay the same, right? And then we get this additional information, all right? And so if we were going to then consider how we were going to estimate the hourly cost, right? Our providing service still remains the same at $30 plus $10, right? So that's our $40 cost because we've got the server and we've got the lines, okay? And our waiting cost, right, is still our $4 per minute times 60 minutes per hour. And what's my I sub I in this case? The number of people that are waiting.
0.788.
Right, so it changes to 0.788, so I multiply that by 0.788, okay? And if you'll note, I gave you the formula up here for your margin loss due to blocking. It's your cost per time times R sub I times R sub P, right? And so that applies now that we're in a finite system. So I can go ahead and come down here and I can say, well, my cost per time, in this problem it says it is $150 per frustrated caller. So it's going to be $150, okay? And then it says times R sub I, which is the arrival rate, times the probability of being blocked. But if I go to my printout from performance.xls, I can see that it actually multiplies that for me already, right? I've got R sub I times the probability of being blocked. So you can either take those two pieces of information individually, or you can just take it right off of the spreadsheet, right? And so that's going to be times 0.0163, 0.01603 right? And I'm going to finish the math on those and add those up to get the total cost. Okay? So now that we've gone back over that, is that refreshing your memory a little bit? Okay? And
Are
yes,
you going to give us the formulas on the test?
I'm going to give you the exact formulas that you see there on the test. Okay? And then in the exact same way. Okay? So, again, I'm not very creative. I think you'll see a little bit of, in terms of, we talked about 3 different possibilities in terms of increasing the number of Watts lines, decreasing the number of Watts lines, and combining them up. You need to be familiar with all 3 of those scenarios. You need to be familiar with the terminology, and you need to get comfortable calculating this hourly cost and reading the spreadsheet. And you'll also be asked what are the values that I would put into a spreadsheet, right? That's an individual question. So I'll give you a problem and I'll say, tell me what C should be, tell me what K should be, tell me what R sub I should be, and tell me what 1 over T sub P should be. So you need to go back through those and make sure you're comfortable. They're not hard. I think you just need to do a little bit of practice with them. So I'd go back. All of the 8 homework is available. I'd go back and review that, make sure that you're comfortable with it. That's really all I've got. And so that being said, best of luck to everybody. I think our exam is in here on Wednesday. It's at 12:30.
Oh, is it 8?
Yeah, it's at 8.
It's 8. Okay.
Do you want to
I mean,
finish
we
at
can do
12:30?
12:30.
Yeah.
I don't know.
I'd rather get it over with.
Yeah, my brother.
Hey, Kaylin, can you reserve tables at Jay's?